Your network just died, and the AI managing it doesn't know. No log entry, no alert triggered, no notification pushed, just silence. And a business that's already bleeding. What you're about to see isn't theoretical. It's a documented failure pattern happening inside enterprise networks right now. And the engineers responsible have no idea until the phone rings. Stay with us. By the end, you will know exactly what to look for. And more importantly, what no AI on the market is looking for yet. For the last decade, the industry chased one promise: automate everything. Reduce human error, speed up response time, build networks that think for themselves. And it worked. Intent-based networking, AI-driven routing, self-healing architectures. These aren't concepts anymore. They are deployed, they are live, and they are running your infrastructure right now. But here is what nobody puts in the pitch deck. AI system fails in ways human never anticipated. Not with explosions, not with red alerts. They fail quietly, drifting out of spec, routing traffic through compromised paths, making decisions based on corrupted baselines and logging none of it. 73% of AI-managed outages traced to anomaly blind spots, 6.5 hours average detection delay versus human-monitored environment, and $5.5 million average cost per hour of enterprise network downtime. To understand why this happens, you need three concepts. First, what AI actually does in modern networking. It monitors traffic patterns, adjusts routing tables in milliseconds, predicts bandwidth load, flag anomalies, and execute policy changes, all without a keyboard. At scale, no team of humans comes close. Second, where humans still own the room. Strategic architecture decisions, security policy design, regulatory compliance interpretation, vendor negotiations, and critically, judgment calls when context matters more than data. Third, the hybrid model. The organizations getting this right aren't choosing between AI and humans. They are building a command structure. AI as the execution layer, humans as the governance layer, different responsibilities, overlapping authority. Let's get specific. Modern AI network analytics platforms, the kind deployed across Fortune 500 environments, use machine learning to establish behavioral baselines for every device on a network. When something deviates, they flag it. Sounds bulletproof. Here is a flaw. Case study 1. Missed AI VLAN crossover incident. A wireless enterprise environment, 11 days undetected. An AI-driven wireless access point system, the kind that auto-optimizes traffic routing across hundreds of devices, began routing guest network traffic through the production VLAN. The AI saw nothing wrong. The guest traffic was technically valid. It matched the authentication rules. Every policy it was trained on said proceed. Day 1. AI reroutes guest traffic through production VLAN. No alert generated. Traffic is technically policy compliant. Day 4. 0 abnormality flags in the dashboard. AI compares current state to recent baseline. Both are now contaminated. Day 11. engineer notices unusual packet latency during a routing capacity audit. No automated alert triggered it. Human pattern recognition caught it. Day 12. Root cause identified. Policy inheritance bug combined with no human override checkpoint. Production and guest VLANs have been breached for 11 days. 11 days, the AI wasn't broken. It was doing exactly what it was trained to do. The problem was that its training data had no example of this failure mode. That's the baseline poisoning problem. If the reference point drifts, everything the model compares against looks normal, because by its own logic, it is. The job roles shifting here aren't disappearing, they are transforming. The engineer who was configured VLANs manually now need to understand why the AI made a routing decision, trace the logic chain, and identify where the model diverged from intent. That's a harder skill set. It pays more, and most organizations haven't trained for it yet. Here is the argument you won't hear from vendors. AI cannot govern itself. Not because it lacks processing power, not because the models aren't sophisticated, because governance requires something models don't have: accountability to consequences. When an AI system quarantines in production server because it matched a thread signature, without knowing that server was mid-transaction on a $2 million payment batch, that's not a bug in the software. That's a gap in this architecture, a system designed to optimize for security deployment in an environment where security and business continuity are sometimes in direct conflict. Ethical oversight, legal liability, security clearance decision, context-dependent triage. These live with humans, not because we are sentimental about it, because the blast radius of an AI getting it wrong at scale with no human checkpoint is catastrophic. In that domain, and why AI cannot own this. 1. Security escalation triage domain. AI identifies threats. Humans authorize the response. Blast radius requires accountability. 2. Regulatory compliance domain. GDPR, HIPAA, SOX interpretation requires contextual legal judgment no model currently has. 3. Architecture strategy domain. No model knows your 5-year budget reality, vendor relationships, or risk tolerance. 4. Cross-system impact assessment domain. Only humans see the full operational picture across business units. Their framing isn't human versus AI. The framing is human as system governance, setting the boundaries within which AI operates, auditing its decision, and retaining override authority. That's not a power struggle. That's responsible engineering. Where does this go? Not toward replacement, but toward elevation. By 2027, Gartner projects 60% of enterprise network operations will be augmented by AI in some capacity. But the word augmented is doing a lot of work in that sentence. Augmented means AI handles volumes, human handles judgment. And the gap between those two responsibilities, that's where the next generation of network carriers lives. For an AI network supervisor, they would monitor model behavior, validate decisions, and own escalation protocols. An automation architect, they will design the intent layer and translate business policy into machine-readable logic. And for an AI behavior auditor, they will read model decision logs like a forensic accountant and find the entry that shouldn't be there. The autonomous network of 2030 won't be unmanned. It will be differently manned. Fewer engineers configuring switches manually, more engineers questioning why the AI made a routing decision at 3 a.m. that nobody approved. Here is where it gets real. Two incidents, separated by geography and sector, show exactly what the future looks like when the governance layer is missing. Case study 2, a BGP route leak in the financial sector. An Eastern European bank, 2023, which was left undetected for 4 hours 17 minutes. In 2023, a regional bank deployed one of the most advanced AI-driven BGP management systems available, built to detect route anomalies in milliseconds, autocorrect before a human could blink. What it couldn't detect? A legitimate-looking route advertisement from a compromised upstream provider. The routes were technically valid. The AI's part was clean. Every metric the model was trained on said, "This is fine." The 0th hour, upstream provider pushes compromised BGP advertisement. AI validates AI's parts, accepts as legitimate, no alert generated. The first 3 hours, transaction traffic silently rerouted through adversary node. AI routing dashboard showed 99.2% uptime, 0 abnormality flags, and business runs normally. The 4th hour, a senior network engineer notices latency spikes on a hunch. No automated alert triggered it. Routine capacity check. The numbers felt off. The 4 hours 17 minutes undetected, human override was issued and compromised route withdrawn. Root cause. AI had no training data for adversaries but valid BGP paths. It learned what wrong looks like and not what deceptive looks like. The AI was right by every rule it had and completely wrong by every consequences that followed. That's not a software bug. That's a gap in the architecture, a system trained to detect known failure patterns, deployed in a world that invents new ones every quarter. The engineer who caught it didn't have a better idea. She had a better intuition, built from years of knowing what a healthy network feels like, not just what one looks like on a dashboard. That role, AI behavior auditor, is not a developer and not a traditional network engineer. It's someone who reads model decision logs the way a forensic accountant reads a balance sheet, looking for the one entry that shouldn't be there. Both of the incidents you just saw, the VLAN crossover, the BGP leak, were caught by engineers with that skill set, not because they had better tools, but because they asked the question the AI never thought to ask. That's the skill that matters in 2030, and you can start building it today. AI-driven networks fail silently, not because AI is flawed, but because we deployed it without building the oversight layer first. We celebrated the automation and skipped the governance. The network that stays resilient in the next decade won't be the most automated. They will be the ones where humans and AI have clearly defined authority, where the machine executes fast and the engineers ask the right question at the right moment. The most dangerous network is the one that thinks it doesn't need you. Make sure yours does. Before the call to action, here's what we covered. 1. AI managed network fails silently through baseline poisoning and decision log blind spots. 2. Two-wheel incident. VLAN crossover which was undetected for 11 days and BGP route leak which was undetected for 4 hours plus. Confirming this is not theoretical. 3. Human engineers remain essential as system governance, setting boundaries, auditing decisions, and retaining override authority. 4. The roles of the future. AI network supervisor, automation architect, and AI behavior auditor are already appearing in job posting. 5th, the winning move. Build the oversight architecture before you build the automation. If this changed how you think about AI in your network, hit subscribe. Every week we cover what the certification books keep, real failures and real fixes. The next video covers something engineers don't talk about publicly: how slow-burn firmware vulnerabilities defeat AI abnormality detection for months without a single log entry. Link is above. Watch that one next. And drop a comment below. Has your team experienced a silent network failure? Did the AI catch it, or did a human? I want to know what you found.